Factors influence the size of the zone of inhibition for an antibiotic disc. There are so many factors influence the size of the zone of the inhibition. Drug solubility, rate of drug diffusion through the agar, the thickness of the agar media, the drug concentration impregnated into the disc, the size of the inoculum, the type of the medium, resistant mechanism of organism, pH of the medium, reading of zone, time of disc application, temperature of incubation, incubation time, and proper spacing of the discs. These are the factors influence the zone size. Drug solubility, the solubility difference in the molecular structure of the drugs. So larger molecule will diffuse very slow rate compared with lower molecule weight compounds. Next one, rate of drug diffusion through the agar. So when we consider each and every drugs, they are diffused. The rate of diffusion vary from one to another. So larger zones are obtained when the drugs diffuse rapidly. That means when the drug diffuse very quickly, we can observe the larger zone. If the drug diffuse very slowly, we can see the smaller zone size. The rate of diffusion of the antibacterial through the agar is depending on the concentration of antibiotic which are loaded into the disc and molecular weight of the antibiotic. When molecular weight is higher, so movement is low. The solubility properties of the antibiotic, if the drug is soluble rapidly, so it can diffuse easily. The pH and ionization we will discuss later. Binding upon the agar medium. Thickness of the agar medium, normally when we preparing the agar medium, the depth of the agar should be 4 mm. The plate that are too thin will produce false susceptibility results, as the antimicrobial compound will diffuse further than it should. That means if it is very thin, that means less than 4 mm, actually the zone size very larger, right? If the thickness is very high, it gives the smaller zone of inhibition. The drug concentration impregnated into the disc, the concentration, when the concentration of the drug is increases, diffusion also increase. Sometimes the deterioration of the drug also affected the zone of inhibition. If deterioration is happened, the diffusion, actually the concentration is low, so the zone size is low compared with actual the zone size. The size of the inoculum, the size of the inoculated organism must also be standardized. Here we are using 0.5 normal McFadden standard. We are used to standardize the inoculum. The 0.5 normal McFadden standard, which are prepared by using barium sulfate, which are turbidity solution. We are comparing our organism with the suspension with the McFadden standard. Here, after comparing, it should be same. The turbidity should be same. So that's mean the suspension contain 1 to 2 into 10 to the power 8 colony forming unit per ml. That means when we consider 1 ml of the suspension, it's contain 1 to 2 into 10 to the power 8 colony forming units. drug solubility. The solubility difference in the molecular structure of the drugs. So larger molecule will diffuse very slow rate compared with lower molecule weight compounds. Next one, resistant mechanism of organism. Selection of the antibiotic is based on the type of uh, organism being tested. If the organism is susceptible to the antibiotic, they will not grow near the disc. However, if they are resistant, they will grow right up to the disc. pH. The agar media should have the pH between 7.2 to 7.4 at room temperature, because normally the most of the bacteria grow at pH nearly 6.5 to 7.5. But in the case of Vibrio cholerae, this is normally which can grow the pH 8. So it's need pH 8 mediums. If the pH is too low, that means acidic, certain drugs, amino glycoside example, it will appear to lose potency. That means in acidic condition, some drugs they are lost their potency. That means the strength. So that time we cannot expect the zone of inhibition. So sometimes the what we expect the actual size, but the reduce the zone of inhibition. If the pH is higher, sometimes we can expect the very larger zone of inhibition. The reading of zone, the person to person, sometimes the zone of inhibition vary. So it's also affect the zone size of the zone. The drug concentration impregnated into the disc, the concentration when the concentration of the drug is increases, diffusion also increase. Sometimes the deterioration of the drug also affected the zone of inhibition. If deterioration is happened, the diffusion, actually the concentration is low, so the zone size is low compared with actual the zone size. Temperature of incubation, normally the zone size, depending on the temperature. So if we can see in the larger zone size when the temperature is less than 35 Celsius. Then incubation time, normally we have to incubate 16 to 18 hours. If it is less time, sometimes the zone of inhibition was maybe low, and here the temperature and the time mostly the proportionally it's depend. That means when the temperature increases, then we have to reduce the time. For example, if we are keeping 35 or 37 Celsius, you can keep 16 to 18 hours. But if you are keeping to room temperature, that means 25, you have to keep long time, 2 to 3 days or more than that. That means 3 to 7 days. Okay. Next one, the proper spacing of the disc. When we place the disc onto the inoculated media, the distance between two discs should be 2.5 centimeter. Otherwise, zone will overlap, so we cannot measure the zone size. Thank you.